Hey everybody, this is David with Cyber Antennas, and today I want to explain the motivation for our horn giveaway project, where we are giving WISPs all around the world up to 12 free horn antennas for them to upgrade their existing RF Elements horns. So with ISO horns, we noticed that people would buy our horn antennas for new tower projects, but very rarely would WISPs upgrade their existing RF Elements horns. And with cyber antennas, we are giving away up to 12 free horns so that WISPs can upgrade their existing towers and see the performance improvement in terms of speed and reliability and capacity. So if they have 12 horns on a tower and they get up to 1 gigabit per second through that tower, then they upgrade to cyber antennas and they can see the capacity improvement through cyber antennas in terms of better service to the subscribers and more capacity, more revenue for the business. And importantly, cyber antennas are going to be priced much lower than ISO horns. And our goal there is to make it so that it's practical, it's economically feasible to finally get rid of RF Elements junky horn antennas. But it's not just about providing better service to your subscribers, finally getting those junky RF Elements horns off the WISP tower, improving the spectrum for everyone. It's also about undoing all the miseducation from RF Elements. For the last decade, RF Elements has been telling WISP that the reason why their horn antennas uniquely perform well in noisy environments is because they have no side lobes. They've been repeating this ad nauseum, and they haven't just been lying about the capability of their products. They've been telling WISP they don't need to use other noise mitigation technologies and techniques. So they say the problem is horn antennas are wrongly deployed antennas with huge side lobes. They don't understand. RF Elements has never understood that the reason why horn antennas perform well in noise is because of the narrow beam widths, not because of the reduced side lobes. So when you have a 90-degree sector, it'll pick up noise from the entire 90-degree sector. When you use a 30-degree horn, then you're only picking up noise from that 30-degree sector. So you pick up essentially 1/3 of the noise. But you also concentrate the signal. You lower the number of stations per access point. The stations on average are closer to the center of the beams where the signal is strongest. The polarities are most balanced. So for all of those reasons, 30-degree horns perform well in noise. And WISPs figured this out. So you can look at this tower right here. This is a bunch of 30-degree horns. This isn't their 90-degree horns. Both their 90-degree horns and their 30-degree horns supposedly had no side lobes. But WISPs figured out that it was the 30-degree horns that helped them perform well in noisy environments, scale up their networks, not their 90-degree horns. RF Elements never figured this out. So the goal for cyber antennas, not just to prove that our antennas are better, help you provide better service to your subscribers, scale up your business, but also we want to undo all of the miseducation that RF Elements has foisted on the WISP industry and really set the WISP industry back. Because there's lots of WISPs who believe RF Elements. When RF Elements tells them they don't have to use other noise mitigation techniques like shrouds on their parabolic dish antennas, or here they say that you don't need to use better radios. So they say you don't need GPS sync, you don't need the prism filter, you don't need multi-user MIMO with GPS filtering, and you don't need better radios because you can just use their magic antennas. So you don't need to use other noise mitigation techniques and technologies. they're really doing WISPs a disservice. So here they attribute to the horn antennas 0 side lobes, and to their twist port adapters 0 cable loss. Of course, both of these are lies. This is RF Elements education. This is their webinar on increasing throughput. At the peak of RF Elements in 2021, this is what they were telling WISPs. So we're not just upgrading the antennas, we're also undoing all of this miseducation. You can see here that they attribute to sector panel antennas, they say the side lobes pick up all the noise. You can see that this has a wide beam width, so this is providing a wide coverage area. And then they've got their antenna here, and where is it? There. This has a narrower beam width. So the previous sector panel antenna was picking up noise from over here and from over here. It wasn't the noise surrounding the tower that was causing the problems, that causes the problems. The location noise and interference, guess what? That's fixed with shrouds. That's fixed with GPS sync, which totally eliminates located noise and interference by synchronizing the signal transmissions and receives. Active filtering totally reduces the out-of-channel interference. Multi-user MIMO directs, it just makes it more spectrally efficient, partly with narrow beam widths, with beamforming. And then LTU silicon is similar to active filtering. So it's custom, it's purpose-built fixed wireless access, purpose-built WISP chips. So all of these are very useful for scaling up WISP networks and dealing with interference. But RF Elements told WISP that they didn't need any of these. They could just use their magic antennas with no side lobes, and that fixes all the problems. And because of that, here, WISP did this. WISP would pile horn antennas on top of each other. This worked because of narrow beam widths with all of the other technologies. So with GPS sync, this worked. But without GPS sync, this would be a disaster. So it was GPS sync that made this possible, narrow beam widths that made this possible, not no side lobes. So cyber antennas is not just improving the RF performance. We're not just finally getting RF Elements horn antennas off WISP networks. We're also educating WISPs about how to use our antennas properly. And that's what's necessary today to help fix all of the problems that RF Elements created over the last decade. Thanks for watching.